One of the most common conversion functions you'll find yourself running into in Maya is converting a NURBS surface over to a polygon surface. This literally pops up all over Maya under each of the surface operations. What we're going to be doing is taking a look at going under Modify, Convert, NURBS to Polygons, and taking a look at everything you can do here inside this options box. For starters, though, let me go ahead and create a NURBS surface. I'll create a circle. Let's rotate it in X, 90 degrees. You may have seen me actually do this before on some of the other videos. If you haven't, I'm sure you will sooner or later. We'll go ahead and group this circle to itself. Let's press Shift-D to duplicate with Transform. I'm going to set Rotate Y to about 30 degrees. And then we'll scale this down uniformly to somewhere around 0.89 in this case. And then I'll just hit Shift-D several times in a row to create a nice descending spiral. I'll grab all of these circles. We'll go to Edit, Ungroup. Whoops, I'm sorry. Select them all, press the up arrow key, and then we'll ungroup. Let's go into the outliner. We'll select the first NURBS circle, scroll down, shift-select the 22nd NURBS circle. We'll loft all these together, hold down Shift, grab all the remaining circles with a big marquee selection, and hit Delete. So here's our fabulous new NURBS surface. Let's go ahead and select it and open up our options for the Convert NURBS to Polygons box. Now, the first option you see in here is whether or not to attach multiple output meshes. This is very handy because, as you know, NURBS models are going to end up being made of multiple patches, sometimes hundreds, if not thousands of these meshes. So if you want to convert the whole thing over to a single polygon object, it would be nice if you could have one complete polygon object when you're done. And that's what this is going to do. And within a certain degree in your merge tolerance, it's going to actually weld all of your vertices together excuse me, to make sure that everything stays nice and clean throughout your model. Now, personally, I have noticed that sometimes things get a little off with this. Excuse me. Sometimes things can get a little bit strange with this if you do have multiple meshes. Let me go ahead and take this model, and we'll chop it up like so. And I'll select all of these at the same time and just convert them to whatever settings happen to be in here, like so. And occasionally you may notice at that seam where the two were attached, you may have some extra detail that you may need to go in and clean up. Personally, unless it's going to be a real major pain, like you've got just tons and tons of detail, I will take care of this myself after the fact. I'll go ahead and run my conversion, then I'll bring everything together into a single model, do my merges, and all's good. Let me go ahead and undo all the way back to where I have a single object. And we'll switch off Attach Multiple Output Meshes. You can also use your render tessellation. Now, render tessellation is something that we talk about in the NURBS workflow section, so I'm not going to go too far into it here. But if you switch this on, it's going to read over to your shape node to whatever you have set up to your current NURBS tessellation, and simply apply that so that now you have a new polygon model based off of that tessellation. Really is that simple. Now from here, we have the various types and ways that we can control this conversion when we run it. First off, we have type. Do you want triangles or do you want quads? It doesn't really get much simpler than that. I'm going to be using quads just because they're a little bit easier to read, a little bit easier for you to follow along with in the viewport as I work. And down from here, we have tessellation method. We have 4 methods. We have general, count, standard fit, and control points. Now, 2 of these are very simple, and 2 are a bit more complex. We're going to start off with general. Basically, this allows you to specify, kind of in a custom fashion, exactly what kind of tessellation you'd like in both of the primary directions along the surface, U and V. What I'm going to do, instead of going over each one of the settings one by one, is we'll go ahead and apply this like so. I'll drag my newly tessellated surface off to the side, and we'll open up our attribute editor. And notice I have the NURBS Tessellate 1 node. I can go under Advanced Tessellation Options, and then down under General Tessellation Options like so. So I have all of the exact same settings available to me. It's just now I can adjust them intuitively, and you can see a change in the surface. First off, you have U-type and V-type. Now, I can show you what those do, but it's going to be a little bit easier if I add some detail. So Let me first talk about U number and V number. This is just going to be the amount of detail you have in either direction. So there's the number of polygons we get in the U direction, and then the number of polygons we get in the V direction. Very, very easy to follow. So under our types, we have 3 different settings. We have per surface number of isoparms in 3D, per surface number of isoparms, and per span number of isoparms. By default, you're using per surface number of isoparms in 3D. This is going to read the number of isoparms across the surface, tessellate based off of what it finds, but then it's going to take another calculation that'll evenly space out all of the detail in 3D space. If you switch this instead over to per surface number of isoparms without the 3D bit, you're going to notice that areas where your isoparms were closer together, you'll end up with tighter detail. So it's actually basing the spacing of your detail on the U and V parameterization, how close together all of your spans were. So as I increase V in this case, let's say maybe push it up to something like 64, you'll notice that up here where I had few spans in the V direction, my detail's nicely spaced out. And as I get down here toward the bottom of the coil, it gets tighter and tighter. You can kind of flip-flop back and forth and just pick whichever one of these works best in your situation. Probably in this particular case, it would be best to use per surface number of isoparms as opposed to using 3D, because when I switch over to 3D, you'll notice that down here at the bottom of the coil, things get a little oversimplified. So it's just another way to look at it. So I'll go ahead and set this back over to per surface number of isoparms. Our third option is per span number of isoparms. And what this is going to do is allow you to set a given number of edges for each span of your NURBS shape. So if I set this like so, we get a lot. And if I set this over, we're going to get just a ton. In fact, we're probably going to have to wait a second. There you go. So in each span, we're getting 16 by 64. So you can see really quickly that this would get a little heavy. So let's set this maybe to 5 by 5. And then we get some nice tessellation based on that. So just whichever type you like to use. Down from here, you have the chord height and chord height ratio. We'll start off just by looking at chord height. What this is going to do is use the chord height of your tessellation. Now, I'll talk about what that is here in just a second. But it's going to use that to control how much tessellation you get. And in this particular case, we're probably not going to be able to see much. I should probably simplify things quite a bit. So let me go down to per span number of isoparms. And then you'll notice, as I adjust my chord height, we start actually getting a change along the surface, such that the lower the chord height is, the more tessellation we get. Now let me explain to you why that is. I'm going to come in here to my side view, and I'm going to use the side view kind of like a chalkboard for a couple of minutes. We'll fly way out here to the middle of nowhere. I'm going to switch off my grid. Now, we're going to kind of have a game of pretend here, so loosen up, relax for a second, and let's just kind of work our way through this. Let's say that this, what I'm drawing right now, is a NURBS curve along a surface, like an isoparm, if you will. Make sure that everything is nice and lined up in this particular case. So this is like a cross-section of part of a NURBS surface. Now let's say that this is a polygon edge that is approximating that surface. And that's kind of what you're actually going to see if you come back over to the surface itself. If I come over here, and let's say I simplify things way down, and let's actually switch off use chord height and maybe boost things up a little bit. I mean, you can see where on the original NURBS surface you'd have a nice rounded edge here, but now you have a straight edge. So if you just kind of use your imagination, you have a curve like so, and then there's your polygon edge. So that's exactly what we have here. Now, the distance from this polygon edge to the top of the NURBS curve, that is your chord height. So what the chord height setting is doing over here inside of our tessellation is we tell Maya how long we will allow the chord height to be. And if the chord height of any given area is longer than this number, then we tessellate again until it's shorter. How does that work? Well, let's just come back over here. Let's say, for example, that this chord height was longer than the chord height that we specified over inside of our settings. Then what would happen is Maya would retessellate. It would create new polygon edges, like so. So we wouldn't be using this surface anymore. This is no longer apparent. We now have two sections instead of just one, and now we have two new chord heights. We have one chord height here, and another chord height here. And so it'll check both of these. If both of these fall within the criteria, fine, we stop tessellating. If they don't, if we need a smaller chord height, then we tessellate this as well. Like so, to here, to here, and to here. And you can see how we're getting closer and closer to our NURBS surface as we move along through this. So now I'd have more chord heights to check, and eventually I'm going to get to a point where my chord height is smaller than the number I specified, tessellation ends, and all is good. So that's how that's working. I'll go ahead and leave this example here for now. In fact, let me go ahead and undo back to just my original block, like so, because I may need that a little bit later down the road. So that's how chord height is going to work, which also explains why the lower the number goes, the more faces you see. This is also a nice way to control how much tessellation you get at certain points of curvature. Now down from here we have use chord height ratio. This is going to override use chord height. So if you switch on use chord height ratio, you might as well switch this off. Now, here's the thing about this. There's what this tool does when you use it. There's the intuitive explanation of what's going on here. And there's the internal workings of what's going on kind of underneath the surface. The intuitive explanation is that you have a chord height ratio that will fall between 0 and 1. It'll never get as high as 1 because at 1 you'd have infinite tessellation. And as you move your slider up, you get more and more tessellation. Now, on this particular surface, I really only get an effect between 0.94 and 0.999. The more complex my surface is, the more tight detail it has, the lower this ratio can go before I start seeing an effect. But this is a very simple surface, so I only have this end of the spectrum really to work with. Now let me come back over here to the side view. Here's what's going on under the surface. I've already told you the sort of intuitive response here, where you move the slider up to the end and you get more tessellation, you move it down, you get less tessellation. What's going on under the hood is just a little bit more interesting. You've already seen what a chord height is. It's the distance from the polygon edge to the curve that it is approximating. What the chord height ratio is, it's a ratio to the chord height against the chord length. The chord length is the distance between these two vertices here and here. So you put these two measurements against one another, the measurement of this distance being the chord height versus the measurement of the length between the two vertices of this edge, and you end up with a ratio. Now, internally, that means that the lower the ratio goes, the more tessellation you should be getting. Because, like, let's say, if you wanted this to be, like, say, a 0.2 ratio, right now it looks a little bit larger than 0.2, so you'd have to tessellate again, then check your length versus your height, see if the ratio is less than 0.2. Once it's less than that number, you stop. Now, what's gone on in Maya 7 is they have actually reversed that. They've made it match what's going on inside the NURBS shape node, which, that's a whole lot more technical than I want to get into, because what they're doing is they're taking what's going on under the surface, they're subtracting it from 1, so that inside your window, when you come over and you start playing with your tessellation, you actually have a slider that goes between 0 for low and 1 for high. So it's a little bit complicated, maybe made just a little bit more so by the fact that they're inverting it now, but that's okay, not a problem. And really all you need to be worried about as an artist is the fact that you can use the chord height ratio as another method to control the tessellation you have in the following manner, where low values equal less tessellation, greater values equal more tessellation. And of course you can't go all the way up to 1, because then you'd tessellate all the way up to infinity, and, well, your computer would never be able to handle it, which would be a lot of fun. So, the last thing you have is edge swap, which really isn't going to make any difference until I switch on triangles. And what this will do is swap out edges along your surface to make sure they're pointing in what it calls the correct... and I have a document that failed to print. That's good. So, notice how some of these edges are swapping out. And this is not something that, it's a major concern. We'll go ahead and leave everything kind of bent over in the same direction. So that is the general tessellation type. So let's go ahead and take a look at some of our other types. From here, we have the standard fit type. Now, standard fit requires less input from us. This is kind of like Maya using just a few calculations in order to give us a final tessellation. We have 4 different values in here. We have chord height ratio, which we've already talked about. It works exactly the same way as it does over in general. We have fractional tolerance, minimal edge length, and 3D delta. The way I'm going to discuss these is actually almost in the exact reverse order of the way they're listed. Let me go ahead and click Apply. And we'll slide this off to the side, and let's minimize this. We'll close up the general tessellation options, and this time we'll open up the standard fit options. So we have access to the exact same stuff, just now in a nice slider function that we can play with. Now, chord height ratio behaves the exact same way it did earlier, where low values equal less tessellation, higher values equal more tessellation. So you get up to 1, and then you're very close to infinity. What I want to start out with, though, let me set this way down, is going to be the 3D delta. The delta value gives you your base tessellation. It's like your original grid of tessellation. So as I increase this, what I'm doing is I'm increasing that grid spacing. And let me go ahead and bring my fractional tolerance way down. And the chord height ratio we could kind of play with. I just don't want to mess with it too much. I just want to keep everything down to a minimum as far as what's going on. As you increase the delta, you're actually increasing the space. Here you go. This should be a nice example. You're actually increasing the spacing of this grid. So the lower you go, the more tessellation you get because that grid spacing is lower. The higher you go, the less tessellation you get because that initial grid has, wider grid spaces. So it's kind of the basis. It's where all of the tessellation in this case is going to begin. Up from here, you have min edge length. Now, what the help file is going to tell you is this is the minimum length that Maya will allow each edge to be. I cannot get a single bit of functionality out of this. So if you're out there using your version of Maya and you happen to notice that this is still working, please drop me a PM and let me know, because I do not believe that this little slider actually does anything anymore. So anyways, moving on from here, we have fractional tolerance. You can kind of think of this as sort of an overall tolerance for how accurate you want your surface to be. So this is, of course, building up from the delta. As we increase the fractional tolerance, we get further and further away from what our surface looks like versus what it looked like as a NURBS surface, which you can clearly see here. That looks, well, only vaguely. It's like kind of an artist's concept of what we have over there on the left. But as I lower that tolerance, that means we are pulling closer and closer to the NURBS surface. And that's really all this is going to do. It's going to uniformly tessellate the surface until we pull closer and closer to the original NURBS surface. It's going to be very fine detail in this case. I could say like maybe 0.002, 0.003, and you can see how it kind of separates everything out. All right, so from here we have the chord height ratio, and this is going to behave just exactly the way it did on the last tessellation value, where lower values are going to equal less tessellation. Larger values, as you move up to 1, will give you more and more tessellation. And you can use this in conjunction with fractional tolerance to get a variety of different tessellation outcomes. So just play with these two sliders, and basically you just end up with the tessellation that you think works the best. That's really all there is to standard fit. It's just a way for you to move a few sliders around and control what your final tessellation looks like. So there we go. Let's go ahead and select our surface again, and now things get easy. So if you survived this long, congratulations, because from here on out, it's very, very simple. The count tessellation method simply allows you to give Maya a number of polygons you would like to have, and that's how it tessellates. So we click Apply, and notice I had 200 polygons. Let's do this. Let's go up to Display, Heads-Up Display, bring up the poly count. And this has exactly 200 faces. Maya did a great job here. Let me go ahead and close up my standard fit options, and I have polygon count options. I can increase this number. Notice it's at 496. Maya's going to try to get this value as close as it can. It's actually hitting 480 right now. So be aware of that. Also know that if you switch your polygon type from quads over to triangles, you'll technically get half as much detail because all of those quads are being split in half. So you'll notice things look a lot simpler, but you still have the same number of actual polygons on your surface. So be aware of that. And so there's at 1,000. Notice we actually have 1,026. So it's not an exact number. The algorithm will simply do the best it can to get as close as it can while leaving everything nice and uniform. So that takes care of that. The final tessellation method is control points. And this is about as easy as it gets because you have no options whatsoever. You apply this. And let's see, can anybody tell me what just happened? Okay. What Maya did is it took the CVs of your original object and put polygon vertices at each one and made a surface that way. That's all there is to it. There's really no options for this. You don't need any options. You have now tessellated based on exactly what you saw in the CVs. That's all there is to it. So, I don't know, maybe from here you could go under Edit Polygon. I'm sorry, just the Polygons menu, and you could smooth that out and keep on smoothing to get, the look that you want. So, hang on. Let me play this for a second. Let's switch off Keep Border. I know this is a little bit beyond the scope of how things go, but, just having a little fun. So now we can take our divisions and crank that up until we like what we see. So it's just another method of tessellating out, and then you could just kind of, smooth out until you like what you see. So that is all of the methods of converting from a NURBS surface to a polygon surface. Certainly one of the more involved conversions you're going to find yourself doing, and one of the most common. But be sure to play with these and get used to all of the settings, and that will wrap things up for this video. Thanks a lot.